yeah, man, that's basically how everything, how college goes every single day. Trying to get through the day. Uh, and I appreciate you guys, taking part of the club, because this is part of your time. And yeah, we hope to like use your time the best way possible, right, and to like develop you guys the best we can. Um, but yeah, um, thanks guys for sharing. Hopefully later on in the next Share the Body meeting, we're gonna able to talk more and meet each other uh, personally, right? But yeah, so I think I didn't attend the last meeting, right? But what I know is that you guys have to you guys have to get familiarized with aerodynamics and do like a little bit of research. Did anyone made like a little document like with the stuff they found, like articles, any videos, just to talk what you found? Um, yeah. So does anyone want to share?
Well, for me, in my case, when you go to the Google Drive through Shell, yeah, when you go to the Shell folder on week one, I put a Word document on there that's like a list, to a few articles that I found that, just like talked about aerodynamics, like what materials to consider when making the shell of the car, why it's so important to consider um the efficiency of how aerodynamic the shell of the car is, just stuff like that, just like how in the long term, it helps us with achieving our goal of being more of creating a more efficient car.
Thank you, thank you. Let me try to open it right now. My computer is being slow because of Zoom. Is this one your file?
Yeah, it's that one, yeah. Yeah, so I just put that. I just put that yesterday, but it's a list of a few good articles that I found that like I think really covers everything that we might want to consider when trying to design the car.
Okay. Does anyone have a file that have a document that they didn't upload? It's fine. It's fine if you don't upload. You can upload it later. But if you can have it, if you have it right now, you can. Oh my God, this bar is so annoying. The Zoom bar or worst design. Yeah. So like if you have a document like on you. Oh, I saw this video. This thing is cool. You can like share. Like I can let you share the screen. But so the first thing is what is strategy? Can you like talk about this for a minute? Juan.
Yeah. Oh yeah, it's just talking about like how when a object moves forward, the fluid in this case here, it creates a drag force that kind of acts as a resistance towards that object moving, and so you want to create a design that's very aerodynamic, very I can't find the word right now, but just that it minimizes the
Streamline.
amount of drag to be able to
Uh-huh. Makes sense. Yeah. For sure.
the cars is as efficient as possible.
Yeah, so drag coefficient, yeah, that's a thing. So for like the people who know drag coefficient is a basically you can say like I like to see as like a rating of how much drag the car produces. Given that you guys know now that drag is basically like how much force, well not how much force, but how hard the object is to move through a fluid, right? In this case, wind, air. So the drag coefficient like tells you um, how much, uh, like how like the rating of how much uh, an object, uh, pierces through air. So this is, I think, how you figure out the drag coefficient for a specific object. As you can see, these cars have different drag coefficients. Um, yeah. Oh, this is a car for a similar competition as ours. Believe it or not, it's called a super mileage competition. It's like similar to ours, but it's more technical, I think. Um, yeah, we have to make something like this. So the drag coefficient of like, let me find this one, this car. Drag coefficient of Ford. This is a Ford, what? For Focus, right? Focus. 0.36. That's the drag coefficient of Ford Focus. Now let's find Ford for one F F 150. It's 0.436. So you see how, because it's a bigger uh, vehicle, it creates way more drag, right? So let's find the drag coefficient of a teardrop. Teardrop. It's okay. You see it here. Oh wait, no. I know that's okay. So like a teardrop is like very low drag coefficient. Has a very low drag coefficient. Um, okay. Let me actually open up this image. Okay. All right. So here, look. Uh, if you look at this image right here, you see like the drag coefficient of this sphere will be 0.47, but half sphere 0.42. And then the smallest drag coefficient is a streamlined body at 0.04, which is similar to a teardrop design. So as you can see, look at this design and look how similar it is to to what's it called? Where is it? To this one. See, so that's why it looks like that. That's why it looks like a weird like oval shape, because that shape ends up being creating a streamlined body and creating a zero point 0.4 drag coefficient. So we're gonna end up measuring our drag coefficient on a simulation, or maybe we can calculate it. Well, you guys have to keep in mind this shape, right? And we can talk about later, like what makes a streamlined body. So first, let me go through the article because you brought up really cool articles. Oh shoot, I found it bad. um, let me see.
A few of those articles are, just kind of the same, just talking about aerodynamic drag in a different way.
Yeah. So actually, let me talk about this design. This design. So do you guys like have an idea why this car has this in the back? Go answer one because you probably know, but like, do any of you have like an idea why this car has the back, this thing in the back? You can a
Well,
random idea.
it'll reduce the drag, right?
Something like that. Something like that. Yeah, not that far off. So, basically, if you think, imagine the air was like the air for a second turned they turned like a like a jelly. Imagine the air that we have turns like a jelly, and then you start running in that like jelly space. What will happen is that, of course, you will feel like the impact on you, right? The jelly like hitting you. But what happens is like on the back, it will create like a vacuum, right? Because um, like imagine this is the top view. So like you will go like that, right? Creating a vacuum like that, and then like closing back in, right? So uh, this thing on the back is to prevent the vacuum of air, the bubble of not bubble of air, but like that's empty space from creating. Because what happens is that um, if that vacuum is too big, it will actually like make the car um, like create a force on the opposite direction. Um, did that make sense? I don't know if that makes sense.
No, yeah,
Uh,
yeah, that makes sense. No, I know what you're speaking about. Yeah, that makes sense. Thank you.
yeah, yeah. So that's basically the reason why usually the back of a car like this one doesn't end up like like straight. Like it has like it tries to close in into the end, right? To minimize the vacuum in the back of the vehicle. So yeah, so you can see like a Mercedes right here, it goes back to the end, you know, the air flows back. So yeah, that's a good article to look at. Yeah, so CD is part of the drag coefficient. I like to calculate it. It's just part of calculation. So look here, you see how the air is flowing. You see this little piece right here. This is like a vacuum, and that creates a force in the opposite direction, so like pulling the car backwards. So
Yeah, that article I found like was pretty good at explaining like some considerations we should make when creating the shell of the car. You know, like how the design should look, or like what a bad design like kind of means for us. Like when yeah, just like some negative effects of a bad design, like how it affects drag in the grand scheme of things.
okay, yeah. So okay, yeah. So thank you, Juan, for providing those articles. Um, you know, it's important to know the basics of aerodynamics, because the shell, that's basically what it's going to be. Your knowledge, based on your knowledge, that's how you're gonna create the shell, right? So first you need to understand, of course, how an aerodynamic shape is affected by air. A shape is affected by air. Um, so I suggest, like, if you couldn't look at any articles today or anything, I suggest just try to look up on YouTube any videos. There's actually a really good video I'm gonna share like in the chat later. That if you couldn't have time today to watch anything or do anything, you just watch this video, and I think you get like a better idea of everything, right? But yeah, it's important, right? We learn this stuff. Let me share something else. Let me stop sharing right here and share on my iPad. Hold on. Someone. Okay. Never mind. I thought someone was in the waiting room. Start broadcasting. Okay. So this is my iPad. I'll talk about this later, but okay here. All right, so well, okay, last year, to give you guys some context, last year I wasn't the president, right? I was even vice president. I was like a marketing person for this club. But I ended up working on the shell. This exact part of the card last year. and I created my own little research, right? And like create like a proposal of how I wanted the car to look like. So my idea is to make it look like this type of design, like a racing, like a prototype car. So like if you guys don't know, this is a LMP4 car or like a Le Mans car. So these cars are the most efficient and durable cars that you will find like in the planet. Like these cars, for example, like in the race of Le Mans, they run for 24 hours straight at speeds over 150 miles an hour. And so that means that they have to resist, you know, a lot of like the forces of racing, but also they have uh, to go fast. They have to, you know, um, like make sure like the design is aerodynamic, and also that they don't waste a lot of fuel, right? So they are very cool cars. And when I created my shell, the design of the shell, I based my design on this. But it's a bit hard just because how the chassis is for our car. But like uh, I suggest you guys like to look at different like things, you know, that you're interested on to make your own design. So yeah, so uh, yeah, so I really like this design. Um, so here I have also the little shapes that I showed a couple of minutes ago. So as you can see, the car here, right? The car here is a car from the competition, like a club or school didn't make it. Like it was just like an example of how like the competition wants the cars to mainly look like. But as you can see, they follow this design, and yeah, you kind of see like it's also very like streamlined, and yeah, it's just looks cool as well. It looks better than the one that we saw. That it was like this is the worst design in my opinion. Like it's like a egg, like a half egg. Like I don't like that. So I just want to make our car look cool, you know, not just be efficient, but like look cool. Uh, but yeah, so like here you can see a bit of like how the air moves with different objects. So here you see, here you see there's a wall, and how the air moves behind it. And here these vortices create uh, like a vacuum, right? Like a vacuum here. And if the object is moving this way, then the vacuum is like what's it called? Making a force in the opposite direction. Right? So to minimize that, you know, you can like round it off, you know, like that. But you can see it's an abrupt change in direction for the air. It goes like that, and then it still has a lot of speed, so it's gonna go like that. Right, instead of creating a vacuum here. And then here, resistance is a 15%. And you see how it's a bit less draggy. The air is just flowing around nicely, but this one is the optimum design. You know, the air goes back to its initial path, right? So it requires a lot of creativity to um, create a streamlined design that is not basic, right? You can just, you know, make a design like this one and call it a day. we could do it like that, but we would like to be better than that. Right. So let me show you my initial sketches. I think it's on this one. Oh, no. Wait, don't look at that. So, I don't think I have. Okay, let me see what can I show. Okay, so I guess yeah. So I was playing around with the shell. I mean the design. So like I suggest you guys do the same thing. So like I first created like the chassis, like a little drawing with the chassis on the side view, and I play around with different designs. How I want the different to look, you know. And then, oh yeah, so like if you guys don't know, we are using 3 wheels, right? We are using wheels, 2 in the back and 1 in the front. Uh, in the chassis, I'm gonna show the chassis in a minute. And the chassis looks something like that, you know, how the red thing looks. So yeah, this is one way that you guys can draft your design. But then I solidify my idea into this. So if you guys look, there's the general like shape of the object. So first, like here, there's the bottom, and then there's like the top side. So I kind of like created lines around it to make it look good. But this was just a sketch. But then I made it better. As you can see, this looks so cool in my opinion. I don't know if anyone agrees, but I wish our car looks like could look like this. So this I tried to make it look like a race, like a supercar, you know, like a Ferrari. How the Ferrari, you know, has like the wheel, like the wheel over like the nose. So like the nose always comes down under the wheel, and then it has like the back here, and then like here there's like a little um, like I said, uh, like channeling the air back into its direction. And here's the front, you know. So this is intended to go to the nose. So this is the nose, and is the lines are intended to go towards the nose. Oh yeah, this is a little thing. I was thinking of creating adding like a little logo, like you know how Mercedes have their star like that. So I was like thinking if we could do something like that, and like oh, shoot. And then like maybe like do like a little thing like eco like here like let's see if I can do it like that. That would be so cool. Like, does anyone agree? Imagine, imagine if we could do that. That would be so cool. Yeah. So that's uh my initial designs, but then if we go here, see, RV2. Thank you, Amanda. Yeah, so this is my other design. So look how this one looks more like the other one that I was talking about. Like this one. You see, okay, and it looks like that because of the fin that is in the back. You see, look at this fin, right? And now if you look back here, that thing gives it like that kind of aesthetic. And as you can see, we have like half teardrop designs. Let me actually use this half teardrop designs here for the wheel and then for the driver. And then this, even though it looks like for aesthetic purposes, the purpose of this is so that you know how okay, let me see if I can actually make it look like this. Okay, you know how the air was like going like oh shoot. Okay. you know how the air was going like that, right? So to prevent that from happening, you can create like a wall, right? And so the air, instead of like going like that, it just follows that path like that. So from the side view, you see how it's, like cool and detailed, but like from the top view, it looks like a teardrop design. You see, so that's some one way, that you can play around uh, with the design, with your design. You can make it look cool. Like it's totally possible. It's just being creative, right? So generally you want to make a streamlined design. So like when the air is like lower than from the air is like going this way, like it just doesn't hit like the body so hard, like it just like gradually it just jumps and then falls back. Okay, so and here you can see like I also have the chassis here. uh, you have like the chassis. I first created the chassis. So um okay, so if you can guys see, well, I'm sorry, you guys can tell, but like I actually made a mistake here when I created this design, because this wall is intended for the driver, right? So like the driver will go like here, and imagine this is the driver, right? Yeah. So this wall in our design is actually like it's supposed to be uh, it's like somewhere around here. So that changes the design completely, right? So that's why I suggest to start first with um, with the chassis, creating a little like design of the chassis first that you can like draw on top, with like the wheels, and then you create like uh, your little shell. Okay. So um, yeah. So now I'm gonna show you guys the. Hold on. Let me see how you stop this stop broadcast. Okay. Let me show you the chassis. I think you guys saw it, but like I'm not sure. I'm just gonna show it like anyways, because I'm gonna talk about my intentions, my design uh things. Can you guys see my screen? No. Can you see my screen
Yeah, we can see your screen for the iPad.
for the iPad or this or the computer?
Or I'm guessing you're on the Mac. Yeah. Well, I guess so. Yeah.
Yeah. Okay. Yeah. I
Yeah,
see.
I'm not
Yeah.
familiar with like Mac all that much, but yeah, sure.
Okay. Thank you. Where was I? Oh, so yeah. So the chassis. So this is the chassis. Okay, so if you haven't downloaded Fusion 360, I suggest you download it like this week, of course. And so to get this file, what you do is like you go, you go to the drive. This thing's so slow. You go to the drive. And then go to well, this is the folder you guys have access to. Uh, your folder, the show, because that's where I put it. The show. Hold on, it's loading. Okay, and then resources. I added a new folder called resources. And then here, you see, there's a chassis template step file. So when you load up the program Fusion 360, what you do is that you import the file. So like you go here and then you go uh, upload, I think, and then it will let you upload the file, upload the file into the um, into the program, right? So yeah, so as you can see, let me see if I can annotate on my iPad. Yeah, I can. No. Okay, whatever. Okay, look, so the head of the driver is gonna go here, just like that. The feet are gonna go like that, and the wheels like that. I mean, the hands like that, and the steering wheel should be like that. So, and the wheels like that. You guys can see the drawing, right?
Yeah, I could see a drawing.
Yes.
Okay, good. So, what you could do is, there are many options, of course, but there are two general options. Do it like that, do the shell like that, or you could do it like the cool way of, like, adding that little complexity and making it look like a car. But with the thing with this design, with this design, you have to know where the steering wheel is. Because if you make the steering wheel, if you don't know how the steering wheel is, what will happen is that the shell might be too low, right? So that you guys will have to later on communicate with the steering team to figure out like that. But yeah, so like you guys can like do this later to create like a little draft. We'll talk about that later. But let me open up all the designs. Um, so this is the one of the first shows I created. Low. Okay, so give it a second. Okay, so look, this in my opinion looks really cool, but unfortunately it doesn't work because of the chassis. You see how the chassis is like um extending outside the shell, because what happened, if you guys didn't know, I don't know if I talked to you, because I think I'm being repeating myself with different teams, but I don't know who I'm talking to because I've talked to so many teams. But like, yeah, I didn't get the chassis, the file with the chassis before I made this. So when I put the chassis in my design, I found out that it didn't fit, right? So that's why we're not gonna use the design, even though it looks cool, in my opinion. Okay, all right, yeah. So look, like, so you see how here, like, okay, you see how here, like, it's like looks like a teardrop design. So like, it's like, what was I talking about? Like, you can make it look cool in different ways. So it is still like, it is still like following that kind of like design on the top. On the side, on the side, it has that teardrop design here. You see. So that's just showing you some examples, right? So but the one I was looking for to make was this one. I was this one is better. You guys, I'll teach you guys how to make something like this later because it took me a while. Okay, so like to figure out how to do this took me like 3 hours. But if I knew how to do it beforehand, I could have done it like in 30 minutes. I didn't know the technique of how to do this. So once you figure out the technique, it's very easy to do this. But if you go on, if you go here, it doesn't follow teardrop design exactly like how the other one does. Um, wait, let me actually, yeah. So it goes, the air goes like that, and then like that, right? Which is not an optimal design, but like I did it, like I just was just playing around. Um, this, okay, hold on. Okay, there we go. Hold on. Let me see. I just gotta like the message. Sorry if I didn't answer any messages. It's kind of hard to look at two different devices at the same time. How does the driver chose? Okay. Yeah. It's no. It's a very good question. Uh, the driver, how the driver is chosen is based on who's the lightest person. Whoever is the lightest person is gonna get us, winning a better chance to win. So uh, I I don't know, but like last year I was the lightest person, but this year I don't know. So we're gonna wait everyone at some point and then figure it out. And if that person wants to be the driver, then yeah, there's gonna be the driver. But if they don't, then we'll move on to the next lightest person. Uh, yeah. So if you're pretty light, you might be a driver. But yeah. So look here. Doesn't follow a streamlined design exactly. Well, like a teardrop design exactly, but it's still streamlined because um, the air, as you can see, it goes back and closes back into its original shape, into original path. So the air goes like that, you know, sure. Like that, something like that. Still goes back to its original path, creating little drag. Uh, but yes, that was that. I wanted to share that. At the moment, does anyone have any questions about anything about the design or like any like um, general questions about anything we talk about or any comments? Because I've been talking for like more than half an hour, and I prefer you guys to have a discussion. Uh, but yeah.
I guess like for me, like my one question is, I've never used the Fusion before, but I do plan on downloading it and whatnot. But I have a lot of experience with SolidWorks. Would you say that like a lot of the skills from SolidWorks transfers over to Fusion? Like, is it like pretty easy? Is it would it be like pretty easy to pick up if I already know how to work with SolidWorks?
That's a good question. So someone asked, what is the name of the program? So it's Fusion. Before I get to your question, let me just show uh, this very important. So I hope you guys are on the Discord. Uh, if you're not, please be on the Discord because I'm gonna put like important information there. So if you go on the Discord, hold on, let the Discord go, and you go to resources here. Go to resources. Hold on, let it load. Yeah. So, oh sure, I was supposed to edit this. I haven't done that. But look here, you will find instructions about how to download Fusion 360. Here. So you open this document here. You're gonna get instructions of. Oh my God, I downloaded it or whatever. Fusion 360, and also some tutorials that I put there. But I suggest that you learn on you with more tutorials. They search so that you you're able to like learn about each feature. Sorry, each feature in Fusion 360 really well. So this is the document that could help you get started. So it's free for everyone to use. That's why we are using Fusion because SolidWorks. Sorry, really sorry. You have to pay a license to use the program. And the thing is that you have to have a Windows computer. So I have a Mac, as you guys can tell. I'm done with the Windows computer. That's my personal experience. But yeah, we're using Fusion 360 because it's very it's like anyone can use it, right? It's also very easy to use. So like if I'm gonna go to Fusion 360, so it's very similar to any CAD program. Is very similar to it follows basically the same basics. So as you can see here, you select a plane. Here you can create a rectangle. Let me do center rectangle like that, and then I shoot it to distance of oh my god, like that, right? And then I can. It looks simple, but that's because of the user interface. But it's actually very complex. You can do a lot of things here. So you can do this. So 5. So yeah, I created, I don't know, a little tile. Right. So as you can see, it's very simple. The only difference is that I guess where you look at the bodies, it's different. So here is the body, right? And then here is the timeline. It's a very cool feature of SolidWorks. So you can look the items how they were before, like, or can you look? You can do like a little like replay. You see. So yeah. Let me see. Okay. Well. Oh yeah. So does anyone have any questions on the program? Or it's good. Did I answer your question, Juan?
Yeah, I'm good. I'm good with it.
I think I got a question. Yeah. So if you guys have any other questions or any problems, just send me a text or reach me on Discord. You know, I am here for you guys. Um, yeah, I was gonna say, oh yeah, so like the next when we're gonna meet in person. So if you attend the what's it called, the general body meetings that we're gonna have in October. I haven't decided on the date yet, but we're gonna of course see each other. But like to actually work on this stuff, the next um the next stage will be the building stage. Right now we are in the design stage. In the building stage, we are going to of course build the shell, and for that we need to be physical, right? Um, but right now, because it's not everyone doesn't have to be in the same room to do their own stuff, you know. So it's more convenient to just have you know everyone virtually and design in their own time. So um, yeah. Any other questions?
Yeah, I guess like my next question is like for the next time that we do meet, like what would be, I guess, like how do I put it? Like before coming into this meeting, one of the things that are what we needed to do was like some research on aerodynamic drag. So for the next
Yeah.
meeting, I guess like what's the next goal? What should we look forward to working on for next
Uh,
time?
yeah, yeah, yeah. Yeah. I was gonna get to that right now. Yeah, cause yeah, that's the last thing. I'm running out of time too, so I guess we can move on to that thing, to that into that now. But if anyone has any other questions, you can text me or anything. So what Douglas had, let me go. Where is it? What Douglas had was is this. So we got this done. They should get familiarized. Oh no, the same thing. Is to understand the shelf size, considering the chassis and driving and the driver and wheels. Uh, but what I also want you guys to do is to create Okay, so yeah, create a drawing, right, with uh, with of how you intended, of how you are intending the show to look like. Okay, so yeah, so my plan is for you to if you have an iPad, uh, you can like draw, create like a drawing, like how I did. But if you prefer to draw on paper, you can draw on a piece of blank paper and or graph paper, and create like a design, your own design, right? What I want you guys also to do is that like how I created like a front view, a side view, and a top view. I want you guys to do the same thing, to create a front front view, top view, and side view of the show, how like of a design of the show, how you would like to make it look. Um, and I also want you guys to uh, annotate your design. About any comments, like for example, any features that you decide to add it, like a teardrop design around the wheels, right, and everything. Any cool things, it's for you. It's a time for you to play around, and we're welcoming crazy ideas too. I have my own crazy ideas that I would like to experiment, but uh, the project is for you guys, not for me. So for you guys to work on, right, and play around. So yeah, so um, uh, try to be creative as much as possible. And so this is the dimensions. Like this is are the parameters of the show. So it has to be the maximum height has to be uh, the maximum height is 1,000 millimeters. You know, the the total width is uh, 1,300 millimeters. The length is 3,500 millimeters, the maximum length. So of course, you guys are not gonna deal with that like right now, but it's really important, right? To look at this stuff. And where did I get this stuff? So I got this stuff. Oh shoot, my Mac is gonna die. But whatever. So where did I get this stuff? So you go here on your folder. Uh, and then you go to the main folder. Yeah, so you go to the main folder, sorry. You go to competition registration. Hold on. Okay, and now, we went to the old one. So this is the old competition rules. Okay, and this is the new competition rules for this competition, for the 23 competition. You go there, and then you click on the thing you're looking for, like vehicle design. We were looking at around general dimensions here. So here we jump to dimensions, prototype class. We're in the prototype division, the prototype class, and here you can find the information. So I suggest you guys look into this document as well, because it's basically that's how we're making the car. Um, but I also want you guys to do something else. But for that, I need to show on my iPad. Okay, so uh, okay, so this is a design that Sebastian did, our vice president. So he has the side view, the front view, and top view, but he also have dimensions, right? So Yeah, so I want you guys to do the same thing, to do this, right? But also like create dimensions to make sure they make sense once you go into that CAD program and start designing. I guess like a better example, like another example would be like this. So like, don't worry about the wheels. Oh shoot, don't worry about the wheels right now. I'll give you more information about the wheels later. But as you can see, like this is for the, I don't know if the dimensions of the old competitions are the same as this competition. But like as you can see, I have like the length that is 90, the height is 26, 26 inches, and then the width is 30 inches, right? So I want you guys to do the same, something similar, like to make sure your designs make sense, you know, once you go into the CAD program. Just all of this that we're doing is to eventually go on CAD. And honestly, like it's after like doing a lot of CAD work, you know, what's it called? You know, it's important to create a draft. So, but yeah, so Vanessa, yeah, so basically that was the whole thing. Oh, wait, I think Vanessa already left. But yeah, so yeah, so that's basically the assignments for this for next week. Is just to create a drawing, an annotated drawing with dimensions and notes, and the front view, top view, side view, based on your understanding of how we can make a streamlined body, and also based on your creativity, how you want the show to look cool, you know. But yeah, so that's what we're doing next week. Yeah, does anyone have any questions on the assignment or anything else? All right. Okay. Yeah. So I forgot to mention something else. So, if you prefer to do the design on a piece of paper, what you could do is that you do the design, but then you scan the paper. I'm gonna explain how later, like on the text message. You scan the paper with an app, and and convert the scan into PDF, and then upload the PDF into the folder. You know, and for the if you're gonna do it on the iPad or the tablet, then you do something similar. You take either a screenshot, or if you can, convert it to PDF and put it into the drive. You know, so we can all have our designs in the same place. You can look at them easily. But yeah, that was it. I'm gonna like send a text message about the task later to give you like a concise version. But yeah, that's basically the task for next time you guys meet. Good, we're good. So we finished at 5 o'clock on time. That's crazy. That's crazy. But yeah, guys, thank you guys for coming. If you have any questions, you feel free to ask me anytime, or Douglas. But yeah, we're good for today. Bye, Michelle.